Hi there. My name is Dimitris Charalambidis. I'm a math teacher, and in this video, I will show you how to find the equation of tangent line of a graph of the function f at a given point. To start with, we'll make some drawings to help us. Let's assume that we have the graph of a function f, and let's assume that this one will be the graph of f. Let a point with coordinates x0, y0 that lies on this function, on the graph of this function. At A, as we can all know, we can draw the tangent to the graph of f. And let's assume that this red line over here is the tangent at x0. What we basically need is to find a way of calculating the equation of this line. This is x0 and y0. To start, before we start, since A lies on the graph of f of x0 will be equal to y0. So in place of y0, we can simply write f of x0. Now, let's also assume that we have a random point M with coordinates xy, M with coordinates x, y, lies on this tangent. In a previous video, we learned that the gradient, or in other words, the slope of this tangent line at point x0 is basically equal to f prime of x0, the value of the first derivative of f at point with x coordinate x0. But we know from earlier years that the gradient of a line, is equal to the gradient formed by 2 points of the line. Here, my 2 points will be points A with coordinates x0 and f of x0, and point M with coordinates x and y. The gradient formula states that if we have 2 points with coordinates x1, y1 and x2, y2 respectively, then the gradient of the line passing through these 2 points will be equal to y2 minus y1 over x2 minus x1. If I now apply this theory in my case, I will get, let me create a little more space here for us. I will get now, by applying this gradient formula for my points, that gradient of AB, and therefore gradient of this tangent line, will be equal to y minus f of x0 over x minus x0. But we already know that the gradient of this tangent line is equal to f prime of x0. And this means that these two expressions are indeed equal to each other. Therefore, f prime of x0 is equal to y minus f of x0 over x minus x0. With a cross multiplication, we get that f prime of x0 times x minus x0 equals y minus f of x0, which is an expression commonly known as the equation of tangent line. This is the equation of tangent line at point x equals with x coordinate x0. Now, of course, if we are asked to find the equation of the tangent line of a given function f at a given point, we don't necessarily need to do all this process. We can simply apply the last formula found. Let's see a quick example. Example 1. Let f of x equals x squared minus 5x plus 6 and a with coordinates 1, 2, a point that lies on the graph of f. Find the equation of tangent line at A. So all we have to do in this case is start with the formula. Equation of tangent is equal to y minus f of x0 equals f prime of x0 times x minus x0. Here we know that x0 will be equal to 2. Therefore, we get y minus f of 2 equals to f prime of 2 times x minus 2. All we need now to do is calculate f of 2 and f prime of 2. F of 2 is actually given. It will be equal to, sorry, it's not f of 2. It should be f of 1. Here, f of 1, f of 1, 1, 1. So we have minus f of 1, f prime of 1, x minus 1, and f of 1 was, like I said, given, is equal to 2. If it wasn't given, then we would simply go to f of x, which is x squared minus 5x plus 6, and simply plug in 1 in place of x. By doing that, we would get that f of 1 equals 1 squared minus 5 times 1 plus 6, which is equal to 1 minus 5 plus 6, which is indeed equal to 2. And this means that f of 1 equals 2, and we now need the value of f prime of 1. To find f prime of 1, I'll begin by finding the derivative of f. The derivative of f will be 2x minus 5, and therefore f prime of 1 will be 2 times 1 minus 5 equals negative 3. Now that I have both these values, I'm ready to substitute and write y minus 2 equals negative 3 times x minus 1. And by doing some simple operations like distributive property here, minus 3x plus 3, I can write my equation in the form mx plus c, which will give me the wanted result, minus 3x plus 5. And this will be the equation of the tangent line at this point A with coordinates 1 and 2 of this given function f of x. I hope I explained them as better as I could. I hope this video helped you to understand how to apply theory to find the equation of the tangent line at a given point. But still, if you have any questions about that, you can always leave a comment below, or you can directly contact me on my personal email, which is haralambidisd@hotmail.com. As always, thank you for your time.